So for elimination, sometimes if you look at the coefficients, they don't just line up. 3 and 6, the x coefficients, are not equal. And 5 and 2, the y coefficients, are also not equal. So you might think, I can't use elimination here. I can't add or subtract straight down. What you can do though is look for multiples, or look for least common denominators. For the x terms, if you double the 3, you'll get 6. So what we'll do then is we'll double the entire top equation. And we can rewrite this as 6x plus 10y is equal to 4. I'll go ahead and cross it out now that I've doubled it. And now my coefficients for x are identical, which means I can use elimination. The signs are positive 6 and positive 6, or they're the same. So I will subtract straight down all three columns. 6x minus 6x gives me 0x. Negative 2y minus 10y gives me a negative 12y. And 28 minus 4 gives me 24. From here, I divide by the coefficient of the variable. Remember to keep the sign negative. And I get y is equal to a negative 2. If I want to solve for x, I can plug back into one of my earlier equations. So let's say we had 6x minus 2y is equal to 28. But I can replace that because I now know y is equal to negative 2. And if I do the math, I get 6x plus 4 is equal to 28. I can subtract 4 from both sides. 6x is equal to 24. When I divide by 6, I get x equals 4. And there's my answer. I'll leave it here just for a moment so you can copy down the work if you're trying to. Essentially what I did was I doubled one of the equations. I multiplied it by a specific number that caused my x coefficients to be the same. Let's look at the back. Here, we cannot use that same trick. If I double the 2, I don't get 5. And if I do 3 times 2, I don't get 7. So what we have to do here is look for the least common multiple. And in that case, I could get 10 for the x terms. 2 times 5 is 10, 5 times 2 is 10. Or 21 for the y terms. The smaller one will be less work. So what I'll do is I'll take this entire top equation and I'll multiply it by 5. And this entire equation multiply it by 2. The goal is to create a common coefficient. This will give me 10x for both equations. Let's do it. 2 times 5 gives me 10x minus 35y is equal to 80. 10x plus 6y is equal to a negative 2. Positive 10 and positive 10, same sign, so I subtract. If they were a different sign, I would add. What this does is it cancels out the x, or eliminates the x term, which allows me to solve. So 10 minus 10 gives me 0x. Negative 35 minus 6 gives me a negative 41y. And 80 minus a negative 2 gives me an 82. When I divide by a negative 41 on both sides, I get y is equal to a negative 2. If I want to plug back into the other equation, I can figure out what x is. So let's use the top one. 2x minus 7y is equal to 16. I'll take y and replace it with a negative 2. This gives me 2x plus 14, since I have two negatives. Or 2x equals 2 when I subtract 14 from both sides. So x is equal to 1. What I had to do here was look for least common multiples of the coefficients. I chose a variable to eliminate. I chose x. And I manipulated the equations so that I got 10x and 10x. This allowed me to eliminate straight down, which got rid of a variable. I could solve and go from there.